Very good morning, class. In the yesterday's video, we have covered displacement time graph, and there were three cases in the displacement time graph. First, when the body is at rest. Second, when the body is moving with uniform velocity. And third, when the body is moving with uniform acceleration. We saw how to calculate the velocity with the help of the displacement time graph, and that is by calculating the slope of the graph. In today's video, we will discuss the velocity time graph and their cases. So let's start. So we have velocity time graph. Okay, so we will start with the first case, which is case 1. Body is at rest, right? Body is at rest. Now obviously when body is at rest, that means the time is continuously changing, but body is not moving, right? That means body is stationary or velocity is 0, right? So what will be the graph? Graph will be like this. A simple blank graph. Because suppose if I make any line in this graph, suppose I make this line, it means that body will have some velocity. Okay, so the body is at rest, it will be a blank graph. Okay, so let's see what is the next case. Case number 2. Body, what was case number 2 in the displacement time graph? Body is moving with uniform velocity. So same case is here also. Body is moving with uniform velocity. Okay, body is moving with uniform velocity. So uniform, that means it is not changing with time. So you can make any parallel line to the time axis like this. This line can be above this line or below, right? But it must be above from the origin, because at origin the velocity is 0. So any line which is parallel to the time axis represent the graph of uniform velocity. I will discuss how these graphs are important, right, and how we can calculate other quantities like acceleration and displacement with the help of graph. But let us first cover the types of graphs, right? So this is your second type of graph, when the body is moving with uniform velocity. Now what was the third case? Third case was when the body moves with uniform acceleration, right? It means that body is moving with increasing velocity. Okay, let's see how the graph can be formed. Now one thing is here, it is not necessary that the velocity always increases, right? That means body always have acceleration. There's a condition that possible that velocity can increase or decrease. That means velocity can have uniform acceleration or retardation. So let's do the third case. So in third case, we can say that the third case can be divided into two parts. First, when the body is accelerating, and second, when the body is retarding. Okay, so this is third case, and body is moving with uniform acceleration or retardation. Right. So I have divided this into two parts. First here A, here it is moving with uniform acceleration. Okay, so uniform acceleration means the magnitude of velocity will increase with time constantly. It will be like this. Okay, and the case of when body have retardation, it is a B case, uniform retardation. Okay, so in case of uniform retardation, body will have some initial velocity, and as the time passes the velocity of the body decreases constantly. Okay, so graph can be formed like this. This is time and this is velocity. Let's say velocity of the initial velocity of the body is here. It can be anything, right? Now as the time passes, velocity is decreasing. So here velocity is increasing. So how can be made a graph when velocity is decreasing? That will be like this. You can see after some time of interval, this graph touches the time axis, and you can see here at this point velocity of the body is 0, right? That means body is moving, and after some time it gets the velocity of the body start decreasing. So obviously after some time the velocity will become 0. Okay, so you can see here at this point, at some interval of time, the velocity of the body become 0. So these are the basic 3 cases in the VT graph. Now let's see why these graphs are significant. Okay, we can say in the graphical representation, VT graph is most important graph. Why? Because with the help of this graph we can find both the quantities displacement as well as acceleration, whereas in displacement time graph we can only find the velocity, and in the acceleration time graph we can only find the velocity, right? But from this VT graph we can find displacement as well as acceleration. So let's quickly see how to calculate the displacement and the acceleration from VT graph. Calculation of displacement from VT graph. Okay, how to calculate? If you remember, I've made a table in which I've written, if you want to calculate the displacement from VT graph, find the area under the graph. So how do we calculate? Calculate area under the graph. Simple. For example, suppose we have VT graph like this. Okay, and this is 0, 10, 20, 30, 40, and the speed is in meter per second, and let's time is 1, 2, 3, 4 and 5. Time is in second. And let's say question says find the displacement covered by the body between second and fourth second. Okay, so we have to calculate the displacement covered by the body from second to the fourth second. As you can see that we can calculate displacement by calculating the area under the graph. So just calculate this area. Okay, What will be the displacement then? So displacement S will be time. How much time is here? Let's say this is T1 and this is T2. What will be time then? Time will be T2 minus T1, okay, and into V. What is V here? V is 30. So find the value. It will be T2 is 4, T1 is 2, that will be 2, and velocity is nothing but 30, so that will be 60 meter. So you can by this method you can find the displacement with the help of VT graph in any interval of time. Suppose let's say one more example. This is example number 2. If graph is, let's say, like this, okay, this is 0, 1, 2, 3, this is 10, 20, 30, okay, this is meter per second and this is second. Question says find the total displacement covered by the body. Okay, so total displacement, that means we have to calculate this area under the graph, which is nothing but a right angle triangle. What will be displacement then? S will be half into base into height. Base is nothing but, you can see it is 3, and height you can see, let's say height is here, it is 30. So answer will be 45 meters. So that's how we calculate displacement from VT graph. Just remember that table which help you to find the quantities. Okay, now as I told you that we can also find the acceleration from the VT graph. So let's see how to find the acceleration. Calculation of acceleration from VT graph. You can see on the board, calculate slope of the graph. Why we are calculating slope, and in the case of the acceleration, in the case of displacement we are calculating the displacement. Look at here, why we are calculating slope. A is del V upon del T. Okay, now just look the graph here. Suppose this is the graph, okay, and we have to find the slope between point A and B. So this is the point A and this is the point B. So to find the slope we must have the coordinates of x and y. So at the x, this is T1 and this is T2, this is V1 and this is V2. Okay, what is the actual formula of slope? Slope is nothing but y2 minus y1 upon x2 minus x1. Okay, slope is change in the quantity on the y-axis, y2 minus y1, to the change in the quantity on the x-axis. This is the general formula. Now the acceleration is del v by del t, or we can write it as v2 minus v1 upon t2 minus t1. Now compare this formula with the general formula of slope. In slope, in the numerator we want the change in the quantity which is on the y-axis, and you can see from the formula of acceleration, in also the numerator is the v2 minus v1, and v is the quantity on the y-axis. Okay, and here x2 minus x1, that means a change in the quantity on the x-axis. So here we can see that time is on the x-axis. So that is why they both are identical, and hence we find the slope to find the acceleration. If time is small, then we write a as dv by dt. When we use this expression, we use this expression if suppose the graph is like this. Let's make it more curved. It is like this. Okay. Now we have to find a slope between very near 2 point. Let's say this is the time t1 and this is the time t2. Now you can see that the time t1 t2 are very near to each other. So we can make a tangent here and like this. So from this point we can find out the slope, okay, by calculating the value of v1 v2 and t1 t2. So in conclusion, we find the slope to find the acceleration with the help of vt graph. So we have completed our two graph, displacement time and velocity time. So it's time to complete our third graph, which is acceleration time graph. In this part we don't have much cases. There are only two cases when there is no acceleration, that means body is moving with uniform velocity, and third when body is moving with constant acceleration. Okay, so first case, case 1, when body is moving with constant velocity. With constant velocity. This is A and this is T. Okay, now velocity is constant. You know that A is v2 minus v1 upon t2 minus t1. Condition is velocity is constant. Now to velocity to be constant, the value of v2 must be equals to v1. Obviously when body velocity is constant means velocity is not changing. Okay, so it means v2 will be equals to v1. So the numerator will become what? 0. Hence in this case A will become 0. That means the graph will be blank, or it will be parallel, it will be along the time axis. That means time is increasing but the acceleration is 0. What is the second case? The second case is quite simple. When the body is moving with constant acceleration this time. Now we have acceleration. Okay, it's quite simple. Like in the previous example, the velocity was constant. So if velocity is constant, it will not change with time. So just make a straight line like this. Okay, it is constant. Like example, when let's say a body is falling freely from some height, so that body is acted upon by gravitational force, which can be taken as constant for that height, because see, basically the value of gravitation changes with height, but this change can be taken as negligible if the height is too small. So, okay, so let's suppose you throw a stone from the roof. So the gravitation on the stone at the roof and at the bottom will be same. If gravitation is same, then acceleration due to gravity will be also same. That means that stone is acted upon by a constant acceleration, and the graph of that stone will be like this. Area under the graph is calculated to find the velocity of the body. Okay, so if you want to find the velocity, just find the area under the graph of acceleration in time. So today I have completed all of these three graphs. You'll get more idea of this graph when we'll do some numerical based on this graph. Okay, next video I will make on the a small basic of the integration and differentiation part, because the next part we are going to do in this chapter will require some basic knowledge of integration and differentiation. So please don't miss out the next lecture, because if you miss out that lecture, you will find very difficulty in understanding some concept in the physics. Thank you so much, class.